And so it should be right over here. It should be negative 2/3, which is close. Okay, so the b value is a compression. And of course, if b is negative, like this over here, 2 to the power of negative 0.5x, well, we have a horizontal stretch by a factor of 1 over 0.5, which is actually 2. So everything is doubled from the original graph here. And it's also reflected about the y-axis. Okay? So just like b did before, b reflects everything sideways. Okay? Sideways. Yeah. Okay? So I'll just go over real quickly here that how they got this blue graph. Okay? So this one right here, this dark blue, if 0.5 is b, that means everything is doubled. So this point actually doubles to that point. 1 goes to 2. And then the negative reflects it about the x-axis, so it goes over here to negative 2. See that? 2 goes to 4, and then reflects to negative 4. And that's how you start to build that. Okay? B? We got B? Questions? All right. So then the h value again, and the last two I think are really straightforward. Although with exponential graphs they look a little bit funny. But oh, where did h go? Did I miss h? Oh, okay. Got them in the wrong order. Sorry. So h is next. All right. So h is the horizontal translation. Trying to find any color there. Just like it was in all of the other ones, but it looks a little funny, doesn't it? It's y equals, and you have some base value. In this case, they have 6 as a base. And then you have x plus 2. That's this one right here. Okay. This plus 2 is in the exponent position with the x. Okay. So we have an a value of 1, right? We have a b value of 1, and we have an h value of actually negative 2, which moves it left, but because this shows up as a plus, we know that it moves left. So if you have your base function here, everything moves left 2 units. So this point right here would go 1, 2 units over. This point would go 1, 2 units over. This one, 1, 2 units over. So just a straight translation. Where you have a positive here, a plus, that means it goes left. And where you'd have a negative, so the negative down here, x minus 3, that means it goes to the right 1, 2, 3 units. Questions? Okay, and then finally, k. K is the vertical translation in mapping notation, which you've been seeing here on these pieces, is basically you take the y values and you add the k value to them. So if you have a plus 2, and notice that this plus 2 is not in the exponent position. It's not up here. It's actually down, down here in the same line as the y and the 4 and the 2. So that means it's a vertical translation. If it's up here, right, whoops. I don't know if this is going to work. Nope, not going to work. So if it's up here with the 2, that's a different story, right? That's left, right. But if it's down here, it's up or down. So plus 2 means that everything goes up 1, 2 units. 1, 2 units. Even this one, 1, 2 units. It looks like the graphs kind of collapse a little bit here, doesn't it? Okay? That's just because, the graphs kind of start to get steeper and steeper. And so they kind of start to look like they come together there. They really don't. They're the exact same graphs. They're just moved up and down, but that's what you'll see if you graph them simultaneously. It'll look like they're coming together at a certain point, but they aren't. Any questions? So here's a question from your assignment that you might have trouble with. Explaining the transformation should be no big deal. But it says, without using technology, okay, so you can't use your graphing calculator to try and match this up. But what they want you to do is to use your knowledge of the characteristics to try and come up with a function, all right? So you know a couple things, right? You would be able to say, okay, an exponential function looks kind of like that generally. That has a, that's yc to the x, right? So that's kind of your base function where this is 1, okay? Obviously this one's quite a bit different, isn't it? But it does kind of look like, well, a reflection here on the x-axis. So that's a negative, what's that, negative a? That's going to look like that. Does that look the same? No, it doesn't actually. It kind of looks like it kind of goes up, right? So it kind of looks like maybe this. Doesn't it look kind of like that? And then doesn't it look like it's been moved up quite a ways? So it looks kind of like that. Okay, that's what that kind of looks like. So if we back that up and we say, okay, where did we come from there? We had a flip, didn't we? We had a flip down here. So that's a negative a value. So let's maybe just say y equals, negative. Okay, and we'll worry about the c maybe in a bit. But we have a negative a value for sure. And then what else did we have? We had this as a flip about the y-axis, and what does that? Yes, b, a negative b, right? So there's going to be a negative in the exponent position there. Okay, and then it looks like it was moved up. Looks like it was moved up how many units? Right? Well, this would have been up 1, 2 units. 1, 2 units. So something like this. So we might have a plus 2 here. Okay? The options. Where are the options? Well, to type in your calculator to confirm, just use the brackets. Now, here's the thing. What we had said was we had guessed, okay, where was it? So we had guessed that we're going to have a negative here and a negative here if we're doing the transformations, right? Well, the other way that it could be done, that's true. That could have been it too, okay? But we were kind of on the wrong track there because the c value, if the c value was between 0 and 1, that would give us an exponential function like this, remember? So the c value, one of the options there that was given, was a c value being a half. All right. So that does the same thing as a flip, and then you flip it on the x-axis, and that's where you get this one. Okay. So if I was assuming the c value maybe would be greater than 1, but if the c value is less than 1, that would do this as well to the graph. So yeah, so it's y equals negative 1/2, and then we found out that there was a bit of a horizontal stretch, and so that was the equation. Okay, so yeah, this question is obviously when you have the options down below, you can kind of piece things together because that is a tough one. You could have that same graph with a number of different transformations actually, so that's why it's a tough one. Okay, so here's part of question number 4. If anyone wants to look up, this is just a bit of an easier one to start with. Plus, you have these options here. So this one right here, with the horizontal line that's dotted, that's the asymptote line, the horizontal asymptote line, which is normally the x-axis, right? So you know right away that this has been moved up 1 unit. If you look down here, your options, this is the only one that's been moved up 1 unit. So you know it's B. But how else can you confirm that? Well, looks like this is has been moved to the right 2 units. So if it's been moved over to the right 2 units, that means that So if this was the y-axis right here, then this would be the base 2 and to the right 2. So this was the original one right here, right? And so this has been moved from here 2 units to the right. So that makes sense there. And if you look at this base, then if you go over 2, and you go 2 squared would be 4. So 1, 2, 3, 4, and it does match up. So it's B.